right, because it's round 2. Okay, so I think let's rock it out. Okay, so where we left off last time was it's kind of calming though. I find it calming. So we're proving this identity, and it asks you which side do you want to choose, the left-hand side or the right-hand side. I can't concentrate with this music on. So, and kind of the reason that I'd left it like that was and saying one isn't immediately obvious, and you'll see I'm drawing a line down here to go, well, let's do it the left-hand side and let's do it the right-hand side and see why it doesn't really matter. So for the left-hand side, this one doesn't jump out, I don't think, and going, well, we've got 1 minus sine x over cos x, and there's no sine squared x equal, well, 1 minus sine squared x or tan x, but there's a 1 minus x, and almost looks like there could be a 1 minus sine squared x, because let's see, what could I multiply this by? Let's do it like this. What could I multiply this by so that we do have in the next step, we want to get 1 minus sine squared x. What should we multiply the numerator and the denominator by? Well, what happens if we multiplied this by 1 plus sine x? 1 plus sine x. Remember, we kind of used this idea of multiplying when we were simplifying those surds. Do you remember a while ago we had like a 1 minus square root 2, and we multiplied it by 1 plus square root 2, and things cancelled nicely and whatever. So again, we could do that. So we've got that, and then the denominator, why don't we just leave it as cos x and 1 plus sine x. Now, our little hint here was, look on the right-hand side, there was a 1 plus sine x in the denominator. So, hey, look, 1 plus sine x, it would be nice if cos x cancelled with something on top. Well, what do you know? 1 minus sine squared x. Let's just get the rest of this down, cos x. And so while I'm writing this, you know that the question's going to be, what can we change the numerator to? Well, 1 minus sine squared x is just the same as cos squared x, which means we can simplify this because that's cos x times cos x, so that kind of squared cancels with that. And we're just left with cos x on the numerator, and on the denominator, we're left with 1 plus sine x, which looks like our right-hand side. So we can finish that off and go, yeah, equals the right-hand side with our obligatory smiley face. So that's if we chose the left-hand side. Now, we could do something similar on the right-hand side. So now knowing that, if we take this right-hand side and we've got our 1 plus sine x, and on the numerator we've got cos x, kind of thinking the same idea in reverse. If we multiplied this by 1 minus sine x, and we multiplied the numerator by 1 minus sine x, well, that's cool, because in our numerator we'd have cos x, 1 minus sine x, and, whoa, that was a bit excitable, and let's do that. And in our denominator we'd have 1 minus sine squared x, which is of course cos x, and one of those cos x is going to cancel with that cos x. So it wouldn't really matter if you chose left-hand side or right-hand side. They kind of relying on the same little trick, because it does feel like a bit of a trick that you see to multiply by this, so you create that difference of 2 squares. And that's really the essence of this. So let's just finish this off. 1 minus sine x over cos x, which is what we had on the left-hand side. So the key take-home from that is that this here, 1 minus cos squared x equals sine squared x, that can be seen as a difference of 2 squares. That's the key take-home from this question, is that either of those, 1 minus cos squared x, it could actually be written as 1, I always like to go this way around, 1 plus cos x, 1 minus cos x. So actually, this second identity kind of expands even further. Sine squared x could be 1 plus cos x, 1 minus cos x. And the same for where cos squared x equals 1 minus sine squared x, you need to think of this as a difference of two squares. And I don't know where to move out the way to, but this could therefore be 1 plus sine x, 1 minus sine x. So this is the key take home from the question. Difference of two squares, see these as difference of two squares. Okay, so that's that last example, and I'm certainly glad we had a bit of a pause in between. Gave me a little bit of energy, and I'm looking behind me at seeing where those dots are coming from, the dots of sunlight. Okay, so 1 minus sine x equals cos x over tan x. Whew. It's just a mouthful to read out these identities. Okay, so you've hopefully pressed pause so you can jot this down if you don't have your workbook with you. And that is 1 minus 1 over here. Okay, so I feel like, again, left-hand side or right-hand side, or both, and why? So I said or both because, I don't know, when I see this and when I practice doing this one, I kind of go, well, I want to take the left-hand side because of those fractions. Because we could do something then, we could immediately go, well, let's have a common denominator of sine x. So we're going to have 1 minus sine squared x, and it's just jumping out already to go, well, 1 minus sine squared x is cos squared x over sine x. So it feels like we've gotten somewhere, and it almost feels like tan x over here. But the right-hand side I also feel like jumps out at me, because for the right-hand side, I want to go, well, we've got cos x over, and let's do one of our nice big things like that, and we've got cos x over, and this tan x we write as sine x over cos x, and well, if we've got cos x over that, that's the same as cos x times by the reciprocal of this, so times cos x over sine x. Oh, well, if we simplify that, we get cos squared x over sine x. Oh, look at that. They're equal to each other. So I feel like that's, maybe I can hide in the middle here. Maybe that's not a bad way of doing it here. Look, we took the left-hand side. We got to a certain point. We kind of stopped. We took the right-hand side because there were some obvious things to get to. We stopped. And what do you know? These two things are equal to each other. So we've shown that the left-hand side equals the right-hand side. I'm not winning here. But that's one way to do it. If you wanted to, and I'm going to just leave this to you to do, if you wanted to and you got to, let's just label, this was line 1, this was line 2, and you took line 2 further, you could turn it into this side. So on the right-hand side, say this was line 1 and this was line 2 and this was line 3. So maybe you did some work to this line 2 and you got line 3 on the right-hand side. I'm going to call this like B1, B2, B3 because it feels wrong to have things labeled 1 and 1. So maybe you did that, and so you actually got to that stage there, and then you kept working it until it looked like the right-hand side. Or you did what we've done here. We kind of took each down to a certain point, and then they look the same. Up to you if you want to do it that way. Okay. Thank goodness for you and everyone that's it, and you've got now a bit of a breather because you can just practice that exercise going into the next lesson. So enjoy that. But of course, you know that we need to, where was that nice music just going?